Hello everyone. Myself, I am Shruti, working as an assistant professor in the Department of Pharmaceutical Analysis and Chemistry and Sri Shanmuga College of Pharmacy. So in this video, I'm going to explain about these Wittig's reactions. So what are all the mechanism involved in this Wittig reactions? I will deeply explain in this video. Now I'm going to discuss an important naming reaction in organic chemistry, which is called as Wittig reactions. So the Wittig reaction is used to convert aldehydes or ketones into an alkenes. In simple words, it helps us to prepare carbon-carbon double bonds. So this reactions was discovered by George Wittig, who also received the Nobel Prize for this work. So now let us understand the basic concept. So in this Wittig reaction, an aldehyde or a ketone reacts with a reagent called as phosphonium ylide. So this ylide contains a positively charged phosphorus atom and negatively charged carbon atom. So this ylide attacks the carbonyl carbon of the aldehyde or a ketone. It leads to the formation of an intermediate compound. So finally, this reaction produces an alkene along with the triphenylphosphine oxide as a byproduct. So this general reaction can be written as an aldehyde or ketone reacts with phosphonium ylide, gives alkene and triphenylphosphonium oxide. Wittig reaction is a method for alkene formation from carbonyl compounds and phosphonium ylides. So it proceeds primarily through the proposed intermediates known as betaine and or an oxaphosphetane intermediates. An important feature of this reaction is called as stereoselectivity. So the stereochemistry of alkene is formed can be controlled by a choice of ylide, the type of carbonyl compound and the reaction compounds. So now let us look at to the related reactions. When the ylide is replaced with phosphine oxide and carbanion, this reaction is referred to as the Horner reaction. So next point, when the ylide is replaced with a phosphonate carbanion, the reaction is known as Horner-Emmons-Wadsworth reaction. So thus the Wittig's reaction and its related modifications are powerful methods for the synthesizing alkanes with controlled stereochemistry. So now enter into the general Wittig's reaction, which is in synthesis of alkenes. So the Wittig's reaction is a simple method to prepare alkenes. In this reaction, the carbonyl compound like an aldehyde or a ketone reacts with the phosphorus ylide. This ylide attacks the carbonyl carbon and forms a new carbon-carbon double bond. So as a result, the alkene is formed. So this reaction is different from aldol condensation. In aldol condensation, the carbonyl compounds reacts with an enolate and usually it forms a enones. But in this Wittig reaction, the product does not need to contain any carbonyl group. So the Wittig reaction is an important and useful method for the preparation of alkenes. So now I'm going to explain about the mechanism of Wittig's reactions. So in this mechanism, first the phosphorus in this reaction, so first the phosphorus ylides act as a nucleophile. So the phosphorus ylide act as a nucleophile. So the negatively charged carbon of the ylide, so the negatively charged carbon of an ylide attacks the carbonyl compound of the aldehyde or an ketone. So first the phosphorus ylide act as a nucleophile. The negatively charged carbon of an ylide attacks the carbonyl compound of an aldehyde or a ketone. So this step is called as nucleophilic addition. So as a result, the intermediate betaine is formed. So as a result, the betaine intermediate is formed. So this intermediate has both an positive and negative charges. So this betaine intermediate compound has both positive and negative charges. So next, the betaine intermediate rearranges to form a four-member ring structure called oxaphosphetane intermediate. So the betaine intermediate rearranges to form a four-membered ring structure called a oxaphosphetane intermediate. So the oxaphosphetane breaks down and it leads to the formation of an alkene as the main product and triphenylphosphine oxide as the byproduct. So the main product is alkane and the byproduct is triphenylphosphine oxide as the byproduct. So when the oxaphosphetane intermediate has breakdown to form a main product as an alkene and the byproduct as an triphenylphosphine oxide as the byproducts. So this reaction proceeds two main intermediates. One is betaine intermediate and second one is oxaphosphetane intermediate. So this is the step-by-step reaction involved in the Wittig's reaction. So once again I repeat first. So the nucleophilic addition reaction. So this nucleophile attacks to the carbonyl compound at the ketone position C double bond O. So this leads to the formation of betaine intermediate. So this betaine intermediate rearranges to form a four membered ring structure called as oxaphosphetane intermediate. So oxaphosphetane intermediate. So this breakdown and it leads to the formation of main product as an alkene and the byproduct as an triphenylphosphine oxide as the byproduct. So this is called as triphenylphosphine oxide as the byproduct and the alkene as the main products. So in this reaction, two intermediates will involve, one is betaine intermediate and second one is oxaphosphetane intermediate. So this is involved in this Wittig's reaction. So now let us summarize the Wittig's reactions. So the Wittig reaction is an important method for the formation of alkenes. So the double bond forms exactly at the position of an original aldehyde or a ketone group. So the double bond forms exactly at the position of the original aldehyde or ketone group. The ylide are neutral molecules, but they contains both positive and negative charges on the adjacent atoms connected by the sigma bonds. So this ylide is prepared via in two main steps. First one is triphenyl phosphine reacts with an alkyl halide through an SN2 reaction. So then this product is treated with a strong base such as organolithium reagent. So reacts with the strong base such as organolithium reagents to form a phosphorus ylide. So these overall the Wittig reaction is a useful and reliable method for the preparing alkanes. So these are under the summary of Wittig's reaction. Thank you so much for watching this video.